Very nice to meet you all. Thank you for having me. Thank you to organizers for a fantastic event. So my name is Axel. I'm the head of business development at Candela for our commercial vessels. And I'm here to talk a little bit about water and public transport, how we can use the water in a more efficient way without destroying it. So how many in here have heard about Candela before? One. Yeah, a few. Good. Soon all of you will know what we're up to. But very quickly, Candela was founded in 2014 with a very firm mission to speed up the transition towards fossil fuel-free lakes and oceans. So we started to develop electric boats, 100% electric, using hydrofoil systems. So I'll come back to hydrofoils in just a little while. We had the first boats in the water in 2017. We had serial production up in 2019. What you see on the screen right here is the second generation that we launched a couple of years ago and is now flying around in many places around the world. But what we've also been working on, and where we believe we can have the most impact in terms of the climate improvements, is for commercial vessels. So right now we're building a ferry that I will mostly focus this presentation on and what we're trying to achieve here, looking at the transport system as a whole. So firstly, I think we all know that water is a fantastic piece of infrastructure. It's already there. You don't need to dig tunnels. You don't need to blow up mountains to get tunnels or so on. So it's already there. It's flexible. It's quite easy to make new routes as you wish. And compared to roads and rails and all these other types of infrastructure, it's quite maintenance-free. But of course, we are exploiting it very heavily, and the technology that we're using today to transport people and goods is not good enough to maintain it as is. So I'd like to show this image, and the boat here to the right for you, it's in the public transport system in Stockholm today, operating on a timetable, and it's built in 1871. So it's over 150 years old. And to the image to the left here, you can see a bus that is built 25 years after this one. So imagine you're standing on a bus stop, you're waiting to go to the office or wherever you need to go, and this bus shows up. It's not really what you'd like to see. It's an interesting thing, it's fun, it's cute, it's charming, but from an energy perspective, it's not good enough. Obviously, there are a lot more modern boats. Engineers have done fantastic improvements in propulsion systems, in hull shapes, and so on, but they've all been fighting against the exact same thing, and that is the massive amount of energy needed to make a boat go forward and push away the water. So as soon as a boat starts to making waves and push away water, there's a massive increase in energy consumption. And that's what we need to try to get away from. So this is what we're up to now. We have a hydrofoil system, and this is by no means a new concept. It's been around for almost as long as the boat you just seen. Croatia has also a very good history of hydrofoiling boats since the 60s. But what we've done is to add modern technology to an old concept that's used physics to reduce energy consumption. So what you can see here, we have a wing and a propulsion system which is submerged underneath the water. And what happens when we move forward at a certain speed, we lift, we take off, and we remove the hull from the water, meaning that we do not need to push it forward. We have as little material as possible in the water. And this is what we get when we do this. It's a massive number that we can reduce energy consumption with 90%. So this is a combination of hydrofoil and a very efficient electric propulsion system. So 90% energy reduction, it's huge. So if I told you that we could reduce the energy consumption with 90% for the aircraft industry, that's unheard of, and it's a game changer. So this also makes us we are allowed to redefine how we're using public transport on the water today, and basically all kind of water transportation. So I'll try to show you what this looks like. This is just outside Stockholm. This is 1.5 years ago, so it's very up and running. What you can see here is that it's basically making no waves at all, so it's extremely efficient. Now, of course, the water here is very calm. There's no waves at all, but it can take a lot higher waves and the choppy waters and just fly over it. And this is more to illustrate the vast amount of efficiency we can get from doing this. So what are then the benefits? Three main parts here. First of all, the environment. Depending on where the energy comes from, the electricity comes from, there's no emissions. The boat by itself does not emit any emissions whatsoever. Since we're not making any wake, and we have a silent submerged system, we're also causing less vibration, and we don't create any shoreline erosions. So for the wildlife and for the environment around, it has a very little impact as well. And looking at it from a lifetime perspective, a life cycle analysis that was performed by the Royal Institute of Technology in Stockholm, we can reduce the carbon emission by 97.5%. So that's taking the material sourcing, the construction, the operations for 20 or 25 years, as well as decommissioning and end-of-life treatment. It's a big, big number compared to similar-sized vessels. Of course, the economy. And I mean, I'm a firm believer that if a solution should be truly sustainable, it needs to be economic as well. And if we reduce energy consumption 90%, we'll also reduce the cost for energy and the propulsion service maintenance with 90%. So we're going from electricity to something else. We're going from something else to electricity. And this is, of course, a massive, massive thing that also allows us to look at how we can use waters in different ways to make it more economical. The infrastructure investments are also becomes very small. So as we consume very little energy going forward, we don't need to bring a lot of energy on board, meaning that we can use small batteries that is not in need of massive charging infrastructures on shore. So we can actually charge our boats with normal charges that we use for an EV. You don't need megawatts for this, you're looking at kilowatts. So overall, the operational cost is down significantly. Then, of course, for the people, the experience. We can travel faster, further. We can travel smoothly. You don't need to worry about getting seasick. We're flying above the waves. It's not slamming at all. And lastly, we're also silent. So you don't need to have all these or the noises from the big combustion engines on board. We have it very silent with a submerged electric propulsion system. So taking all of this into consideration, how can we then translate this to redefining the public transport system that we see today? So as it looks today in many places around the world is that the size of the boats, the capacity, is dimensioned for the peak hours or the peak days or the peak month or the peak seasons. Meaning that a lot of times during the year, it is very, very underutilized. Big ferries moving a small amount of people becomes very expensive and very costly from an energy point of view as well. And what we want to do is want to try to change this so we can replace big ferries with several small ones to get a completely different dynamic in the system. We can have a flexibility to put in boats and move people when it's needed, when it's demanded, and not when it's just there. So get a completely different system in a high rotation. Yeah, I think I talked about this. And I want to bring up this case as well that we're working on now in Stockholm. So we're building the boats right now, the ferries. It takes 30 passengers. And there's a line now in Stockholm where the first boat will run in parallel with. And today there are two boats that takes about 200 passengers each that are going on this route. They have departures every 30 minutes, approximately, and many times they're empty. 2% of the times, it is more than 100 people on board, so half capacity. 60% of the time, there are less than 30 people on board. So it's not very utilized, and have big boats moving empty seats that cost a lot. And what we want to do here is to change this to have 3 boats of ours to do the exact same job as these ones can do today. And what we get then is that we can increase the passenger capacity, the ridership that they have today, with about 15%. We reduce the operating cost with 60%, so it becomes a huge economical incentive here. And these lines, since they're moving a lot of empty seats, there are not too many paying customers, it's heavily subsidized, so tax money that instead can go to something else. Energy consumption, in this case, we're looking at 95%. It's a big, big, big difference. The travel time for the people, the passengers and the commuters, we can reduce the, oh, that's a big fly. We can reduce the travel time by 50%. So today it takes about 50 minutes to go back and forth with the big boats. What we can do is that we can do it in 25 minutes. And the reason for that is that we can go faster because we're not creating any wake and we're not impacting the shorelines. That's why there are speed limits today. So we can save a commuter about 1 hour per day. So 5 hours per week. And again, 0 emissions. So I'll try to summarize what I've just said in a movie. That's probably going to make it a little bit more clear. Let's see if this works. Okay, so this might look very futuristic and like it's far away, but we are building the boats as we speak. So this is a couple of weeks ago in the factory outside Stockholm. The first boat will hit the water the big boat will be in the water after the summer. And the next ones will follow on very, very quickly after that. So we're implementing it right now, and it's very easy to scale up. So if you want to come and try, let me know. We're in Stockholm. You're more than welcome. Thank you. Thank you.